During the course of this presentation, we'll cover periodic engine and chassis maintenance, engine removal, engine overhaul and component reconditioning, and engine assembly. We'll also cover carburetor service, electrical systems operation and troubleshooting, and we'll finish up with fork rebuilding. Now, before we reassemble this engine, we're going to look at some of the individual engine components. We'll cover cylinder head reconditioning, cylinder boring and piston fitting, rod and crankshaft inspection, oil pump inspection, transmission and shift linkage inspection, and water pump reconditioning. Before you start removing the pieces from the cylinder head, remember that each lifter and valve that comes out must go back in the same location. Each component wears a little differently in use. If, for example, you reinstall a number 1 right side inlet lifter into a number 4 cylinder location, it may be tighter than the original. It could stick and cause the valve to hang open. That tends to be hard on pistons. Keep all of these pieces in their proper order. A simple cardboard box with slots cut in it and numbered with the appropriate valve and lifter numbers will do just fine. Since the valve lifters and shims tend to fall out of the head quite easily, remove and inspect them first. If you find any deep scratches or indications of excessive wear on the outer surfaces of the lifter, check the corresponding cylinder head surface as well. Checking the valves for leakage is a simple matter of pouring cleaning solvent into the port. If the valve face and seat are in good condition, no fluid will leak past. Once the valve spring has been compressed, remove the keepers. They, along with the springs and retainers, should also be kept in proper order. Under normal operating conditions, the keepers will sometimes cause a slight burr on the valve stem at the upper edge of the keeper seat. Rather than oversizing what may be a serviceable guide by forcing the valve through it, take the time to remove the burr first. A small oil stone will do the job nicely. With the burr removed, the valve can easily be pulled from the guide. After all the valves have been removed, the combustion chambers and the valve should be cleaned. Combustion chamber cleaner, a product commonly used in the automotive industry, will loosen most carbon deposits and can be simply sprayed on, let stand, and wiped off. Any remaining carbon is then usually soft enough that no hard scraping is required. Whenever you're cleaning combustion chamber surfaces, remember that even a slight scratch can cause a hot spot. With a compression ratio of 10.5 to 1, even a minor scratch could cause detonation. The cylinder head surface should be inspected as part of any reconditioning job. Using a straight edge laid across the head, measure any existing gap between the head surface and the straight edge. If warpage exceeds 0.03 millimeters, the surface should be planed. Since the standard compression ratio is already 10.5 to 1, we don't recommend that you ever remove more than a total of 0.1 millimeter, or about 4/1000ths of an inch. If the surface is that badly warped, you'd best replace the head. And remember, if you machine one head, you should do the other to match. Checking camshaft to cam bearing clearance is next. After placing a piece of plastic gauge between the cam and bearing, torque the cam cap to spec. Make sure the cam doesn't rotate. If it does, your plastic gauge reading will be inaccurate. Remove the bearing cap and take your measurement. If oil clearance exceeds 0.16 millimeters or 0.006 inches, measure the camshaft. Comparing the specs given in your service manual to the actual camshaft measurement will tell you if it's the cam or head that's worn. Inspection of the valves and valve guides should be performed in pairs.
Measure the valve stem diameter and the inside diameter of the guide. The guide must be measured at 3 points: at the top, at the middle, and at the bottom. If the guide is worn, the wear will likely be concentrated at both the upper and lower ends. A worn guide will allow the valve to rock back and forth as it opens and closes. This means that the face of the valve doesn't close squarely on the valve seat. It will tend to close off center and then more or less slide into its closed position across the seat face.
So if the guides are worn, there's no sense in attempting to reface the seats without first replacing the guide. The inside measurement of the guide, less the outside diameter measurement of the valve stem, gives you the available clearance.
The proper assembled clearance for the inlet valves is 0.010 millimeters to 0.037 millimeters. The wear limit is 0.08. Assembled exhaust clearance is 0.025 millimeters to 0.052 millimeters. The wear limit here is 0.1 millimeters. In order to remove or install valve guides, the head assembly must be heated to around 100 degrees centigrade, or a little over 200 degrees Fahrenheit. The guide can then be driven out using the Yamaha valve guide tool or a suitably shouldered punch. Before installing the replacement guide, make sure the positioning clip is properly in place. Once the guide is in place, it must be sized properly to accept the valve stem. The head assembly should be allowed to cool to room temperature before the 6 millimeter guide reamer is used.
The next step involves recutting the valve seats. But before we cover that, let's complete our inspection of the valves first. Using a pair of V-blocks and your dial gauge, make sure the valve is straight. If it isn't, replace it. Next, the seat contact area, or valve face, is stellite coated. This coating more or less does the job that tetraethyl lead in leaded gasoline used to do. It helps stop the valve from sticking to the seat. If the valve face shows signs of minor damage or wear, it can be ground, but only to a depth of about 2 or 3 thousandths of an inch, or 0.075 millimeters. If the damage extends beyond that depth, the valve should be replaced. Refacing the 45-degree valve face should be done by a reputable machine shop. Have them remove only enough material to clean the valve face and advise you as to how much material was actually removed from each valve.
Reconditioning the valve seats is a fairly simple operation if you've got the proper equipment. You'll need a good quality seat cutter set with appropriately sized 30, 45, and 60-degree cutters, and of course, for this model, a 6 millimeter pilot. Start by applying machinist blue to both the valve face and the seat. Fit the valve into the guide and rotate the valve while applying a slight downward pressure. When the valve is removed, the contacting areas of both the valve face and seat should be quite visible. Ideally, the contact area should be centered on the valve face and measure about 1 millimeter or 40 thou in width. If the valve contact area is correct and the bluing has been removed all the way around the seat, a light lapping in of the valve is all that's required. If the valve contact area were centered on the valve face but too wide, you'd use both the 30 and 60-degree cutters to remove enough material to reduce the 45-degree surface to 1 millimeter in width. If the indicated contact area was correct in width, but too low on the face, the 45-degree portion of the seat would have to be moved up or further away from the combustion chamber. Using your 30-degree cutter, remove the appropriate amount of material from the combustion chamber side of the seat. Since your 30-degree cut will have reduced the width of the 45-degree surface, you'll now have to use the 45-degree cutter to bring the seat back to a width of 1 millimeter. Keep in mind that whenever a valve seat is recut, the position of the valve in relation to the center line of the camshaft will change. You'll need to re-shim for proper tappet clearance. One last example. If the contact area were too high on the valve face, the 45-degree surface on the seat would have to be moved down toward the combustion chamber. You'd use your 60-degree cutter to remove some of the material from the port side of the seat. Then, make your 45-degree cut to restore the proper seat width. Depending on how experienced you are in valve seat cutting, you may or may not have to lap the valves in. These new-way seat cutters will produce a nearly perfect seat surface if they're used properly. Chatter marks are usually caused by a loose pilot or too much pressure being applied to the tool while cutting. If you're new to this procedure, it's probably a good idea to practice on an old cylinder head before attempting an actual repair. If you decide that a slight amount of lapping would improve sealing, use a very small amount of fine compound applied directly to the valve face. Make sure to keep it away from the stem. We don't want to lap the guide, just the seat and the valve face. Properly finished, the contact area of the valve should appear dull or matte in comparison to the rest of the valve face. The 45-degree surface of the seat should also appear dull and should, like the contact area of the valve face, be uniform in both finish and width. When you've completed all the cutting and lapping work, wash the cylinder head thoroughly.
Weak or bent valve springs can lead to valve float. Valve float can cause the valve and piston to collide. If that happens, chances are you'll be doing the cylinder head work all over again. Take the time to check each spring visually for cracks and other signs of fatigue, and measure the free length using a vernier caliper. Compare the measured length to the length specified in your service manual. Any spring measuring in excess of 2 millimeters under the specified length must be replaced. Installed length and installed pressure are also mentioned in the service manual. If you've got the necessary equipment on hand, check that as well. If you don't, you'll have to rely on the free length spec alone. Valve timing is quite mild in this engine, so in most cases, if free length is within spec, you'll likely be okay.
No cylinder head reconditioning job is complete unless the valve seals have been replaced. A light coating of grease applied to the guide and seal will make installation easier. Apply a light coating of oil to the valve stem, making sure the valve seal stays in place when the valve is inserted. Make sure both the outer and inner valve springs are installed with the finer pitch coils facing the cylinder head. Installation of the valve collets is made a little easier if grease is applied to both the inner and outer surfaces. This grease will hold the collet in place while the spring compressor is removed. Finally, to ensure that the retainers and collets are properly seated, lightly tap the valve using a plastic mallet. As a final check, again, pour solvent into the port and verify that each valve is sealed properly.
And that's it, a completely reconditioned cylinder head. Remember though, since you've recut all or at least some of these, you're going to have to readjust tappet clearance accordingly. Next, we'll cover cylinder reconditioning and the proper procedures for fitting pistons and rings.